Welcome to the place where we gain knowledge through the lens of creativity. I am Aaron Dworkin, and this is Artful Science. Thanks again for joining me here on Artful Science. Today's show is Sky Mirror, what remote sensing from space tells us about Earth. And my guest is Andy Henry, who serves as GIS and Multimedia Development Consultant at Wayne RESA and Principal Investigator on the NASA-funded AEROKATS and ROVER Education Network project. Andy, welcome to the show.
Thank you, Aaron. That's a lot of words, isn't it?
Right. You know, I find it's this case in science versus the arts. In the arts, we have kind of, violinist, or soloist, whatever. But I think this goes to the, extraordinary complexity of this amazing work that you do. Kind of this whole idea of Sky Mirror, thought I would kind of dive right in. And this episode, which of course is related to kind of this space-based technologies, curated with our wonderful partner, NASA, who's one of our thought partners. And so your kind of specific expertise is really in geographic information systems and remote sensing. So let's just start off, especially for a lot of kind of arts-based people in our audience. What is that exactly?
So we'll start out with geographic information systems. Thank you very much, Aaron, for having me on the show today. I really appreciate it. The opportunity to, talk with you and share this kind of information with the public. Geographic information systems, at its simplest level, is sort of like digital mapping, and you see it everywhere now. Years ago, maps were on paper. A cartographer made a map for a purpose, and you got it. But now with the age of computers, all kinds of data can be mapped. And what we've learned is that most data has what you call a geospatial component, which means it's somewhere, right? Things happen somewhere. Everything exists somewhere. And if you know where things happen and where they are, you can map them. And if you map them, then you can think about what's around them. And so GIS allows you, which is the acronym for Geographic Information Systems, it allows you to overlay different types of data and maps and then do analysis on it, create visualizations on it, share those findings, and come up with new understandings about things. And what we know about the world is that things, unlike a random distribution that you assume in statistics, in geographic information systems, you really assume that things cluster and that nearer things tend to be more alike than distant things. An example of that would be if you're in the mountains in the West and there are lodgepole pines, you would assume to have, say, ponderosa pines, maybe elk around you. You're not going to look for, say, palm trees. You don't expect to find those, or there aren't any manatees there, right? But if you go to Florida, you're going to see those types of things. And you also expect that you're going to sell more, say, heavy winter coats in the mountains in the West. And so you see things sort of cluster that way, and you're not going to see them in a place like Florida. So GIS kind of works on those principles. And, we see it everywhere in our lives now. It's in the newspapers. You see COVID maps, you see maps of migrations, you see, maps of forest fires and then how they're spreading, and drought maps, things like that. That's all done in geographic information systems.
Gotcha. So yeah, this is fascinating. And so is all of this, if you will, space-based? So in other words, how is this utilized with NASA satellites? A lot of times, and certainly previously, I used to think NASA is kind of looking outwards, right? And everything NASA is doing, other planets, the sun, how would we look outwards? But a lot of this is obviously using kind of space-based technology, but looking back at the state. So I guess kind of a two-part question, but is this all space-based technology that we're using to do this mapping? And kind of how does this connect with NASA satellites?
So that's a really good question, Aaron. So as I said, like 80% of all information That's at least an estimate that's been put out there, has a geographic component. So a lot of it's stuff that's collected on Earth. But on top of that is remote sensing, which is and that's basically looking at something from a distance or measuring something from a distance without direct contact. And NASA has all kinds of satellites in orbit that are always looking at the Earth. And they're providing all kinds of information about the Earth from this global perspective that we can bring into GIS and the geographic information systems, and we can add those as layers to our maps and start to understand different contexts for what's happening on the ground, on the sea, and how our human infrastructure right over that interacts with it. So, an example of a remote sensing, simple remote sensing system is a camera. Light strikes an object and then bounces off it or is absorbed by it at different amounts. And there's a sensor in your camera that collects that information and turns it into information that we can look at, a picture, a file, something like that. So satellites carry things like cameras on them. They're looking at the Earth all around, and there are different types of them. So a satellite is, in the remote sensing world, is called a platform, and it's something that carries instruments. So the instruments are what are looking at the world. The satellite is the thing that carries them in space. And NASA has an Earth observing fleet of around 30 satellites that's continuously looking down at the Earth. We have more satellites looking at Earth than any other planet in the solar system. It's kind of amazing, but Earth is important, right? Earth is where we live. It's where, if we're going to flourish as human beings on the planet, we really need to understand what's going on. And what makes remote sensing so powerful is that global perspective. So if we're trying to understand climate change, for instance, say we want to understand how we're losing ice and glaciers. Are they receding? Are they, getting smaller, getting bigger? Are continental ice shelves changing? We can't go and measure all of them. We can't stand there. There are places we can't even get to. But with the view from space, we can see the whole picture.
Wow.
So
Wow.
they help us to understand that. Go ahead.
Yeah, no. So, and it's absolutely fascinating. And I'm also just realizing that perspective and how important that is to kind of see, especially these globalized trends that are occurring that we might not otherwise know. And so is Landsat 9, is that an example of this type of project?
It is. So Landsat is sort of the flagship of the NASA remote sensing system. It's actually a partnership with the U.S. Geological Survey, USGS, and they've put the first Landsat up in 1972. And we have had a Landsat satellite in orbit ever since. So we're coming up on the 50-year anniversary of that, which is pretty amazing. So we've had 50 years of continuous whole Earth imagery, and we've been able to observe through Landsat deforestation, climate change, glaciers changing, ice sheets melting and getting smaller, population growth, development, increases in impervious surface, things like that. So all of these changes over time are documented from space, from this one platform, this amazing Landsat system. And they're going to launch Landsat 9. It is now scheduled for September 22nd. So if any of your viewers see this before September 27th, Landsat 9 is going to launch. Currently, Landsat 7 and 8 are still in orbit and operational, but they're, as their lives extend, they want to make sure it's always over that. So we never have a gap in that data. It's so important to scientists to be able to see that continuity of data over time.
It's extraordinary, and especially it's still just weighing in my mind this idea that we have more satellites facing back and looking at Earth than we do looking outwards. And of course, it makes sense, but we don't often think about that. And of course, how important this information is to understand what's happening to us globally. And so the AERON, if I'm pronouncing that right, the AERON project, kind of how is that associated? And especially I'm curious about public access. So obviously a lot of scientists have access to this. They can look, and climatologists can look and see various things and shifts that are happening. What about kind of public dissemination of all of this information that is being gathered about us, about our world?
Well, that's a great question. So just, I'm going to back up 1 second before I talk about the AEROKATS and ROVER Education Network, which is what you were referring to, the AERON project. NASA makes its data directly available to the public and to scientists and research. So all of NASA's satellite data can be accessed. The raw data, processed data can be accessed. There are sites like the Earth Observatory, where it introduces you to what's going on, especially with Landsat. But Earth is Art with the USGS site, and which I think would spark something with you. Just gorgeous pictures of the Earth from space. I don't think there's anything more beautiful. And then Landsat Look with USGS, where you can also gather data. But with our project, with the AERON project, it's really about introducing remote sensing to learners of all ages, but our primary focus is sort of upper elementary through undergraduate. And we use these sort of novel technologies developed at the Goddard Space Flight Center called AEROKATS. I'm going to show you one, if that's okay.
Cool.
And this one first. This is an AEROPOD. It's a aerodynamically stabilized instrument platform. This one has 2 cameras. One gets visible light and one gets near infrared. And we fly kites up to about 500 feet, and we attach these to the kites with tethers, and they image the ground surface and allow us to do our own remote sensing, just like a satellite. We use the same kind of tools that you use to process it. And then it gives students the opportunity to actually do their own remote sensing, collect that imagery, understand that process that you use with satellite data, which they can also use. They can also use satellite data themselves, but this lets them validate that. It's like, if I can collect the imagery, run the processes, see that it actually gives me the information that it's supposed to, I can sort of trust that that's what's happening with the satellite imagery and what NASA's telling us about the Earth from space. So we think that's really exciting. We have lots of different types of AEROPODs to collect different kinds of information. We also have a couple other platforms, a rover, which does water quality. It's a remote controlled craft, and a Terra rover, which is a land-based remote controlled vehicle that currently is measuring surface temperature to look at urban heat island effects, and which is of course a social justice issue now, because people in urban environments, especially poor people, disadvantaged people, are much more affected by urban heat island than say more affluent people. So
wow,
we're trying to get students excited about science and thinking about, say, careers in NASA using technologies.
It's truly amazing. And I love even how you touched on that about, for example, this impact in urban environments with heat islands, and that this isn't just kind of this, abstract data that's out there and kind of, isn't it nice that we now know that, a glacier is changing, but this directly affects our everyday lives, whether we're an artist or a scientist or everyday layperson, whoever it might be. This is everything that really affects us as a society. Is truly, truly extraordinary work. So we're almost out of time, but I always like to ask of all my guests, since we're at the intersection of arts and sciences, do you have kind of either an arts, discipline you love to practice yourself or that you love to appreciate?
Oh, it's a really good question. So I love music and art. I have 2 sons who are both involved in music, but my background, my undergraduate was in painting and sculpture. And I've worked for several years painting billboards when I got out of college with my painting degree. And then I worked at Detroit's Pewabic Pottery for several years, was involved with that before I moved.
Wonderful, well-known institution in Detroit.
So the arts are very big in our house and in my life. And I continue to draw. I haven't done sculpture for a few years because I've been very busy with science. But I'm looking to get back into that too. So
Truly, truly awesome. Well, Andy Henry, thank you for helping us gain knowledge through the lens of creativity here on Artful Science.
thank you, Aaron. It's been great talking to you. Have a great day.